And there we go. So, problem one. And we need to do the y for it. So we have graph flow shows plot of position versus time for an object moving in one dimension along the x direction. So what do you note? Some things to notice. We have a plot of position versus time. How's that related to velocity? How's the position time graph related to velocity? Black Chuck 2. Okay, so the change, there you go. Excellent. Velocity is the change in position over a certain amount of time. So that's the first thing I would have in here. Velocity is change in position versus time. How does that show up on a graph? Looking for that mathy word. It's with an S. Slope. So the velocity is the slope of the position versus time graph. And then we also need to remember, and if I look down further in the problem, it starts talking about acceleration. All right? And I know that the acceleration is how the velocity changes with time. So this is showing that I understand what's going on here, and so this, I'm looking to see if I need to graph my acceleration, and I don't. How the velocity changes with time. So again, you might also indicate that the acceleration is the slope of velocity vt. This is the slope of pt. All right, so that's, now I don't really, I don't get on my skin how you express those ideas. But that you express those ideas is what I'm reading your why to look for, that you understand those things. Okay? Velocity time graph, sorry. Yep, position time graph. So let's see. I need that graph, so let me grab that graph. All right. So, first part says, what is the speed, magnitude, of velocity of the object at 2.5 seconds? So at 2.5 seconds, I'm looking at this point right here on the graph. No, you don't need to. That's where I'm showing it up here, but to make it, but you should be doing this on a separate piece of paper, not right on here. Yeah. So I know if I'm looking for the velocity at that point, I'm looking for the slope at that point. And I remember from math, it's rise over run. So let's see, my rise. Oh, it's that way. My run is that way. My rise is from 5 to 1. So what's my rise? My rise is 4. So I'm looking for the slope, which I know is rise over run. And my rise here is actually -4. What's my run? 1 to 4, which is 3. Gives me an answer of -1.33. And let's see, this was 4 meters. seconds. So 1.33 meters per second. Generally, give me answers in 3 sig figs, please. Why there's no line up top that 3. And now it says, the question actually says, what is the speed? The magnitude. So should I have the negative there? No, because it's just the size. So the correct answer for this one would be 1.33 meters per second. Then I go to the next question. What direction is the object moving along that time? What direction is it moving if it's negative? Okay? We can say left. Moving 1 minute along the x direction. So we can say negative x, right? Which would be left by convention. Good. What is the acceleration of the object at 2.5 seconds? Tom? Nope. Good try though. Remember, that's our speed. So we look at this and we say, oh, that's a constant slope. An acceleration, and so that's a constant velocity. So it's a constant speed. What is that? How much is it changing? It's not. So what's the acceleration? 0. So constant speed. And I can tell that because this line is straight. Accel equals 0 meters per second. Wow, we're just cranking. That was, what is the acceleration object at 2.5 seconds? Yes, I'm listening. You got constant. Graph below plots velocity versus time for an object. Different from the one in part A, moving one dimension along the x-axis. What is the speed of the object at 2.5 seconds? I'm going to extend the page a little bit more. Let's grab this one. No, we're still, this is all, question 1's a long question. What is the speed, magnitude of the velocity of the object at 2.5 seconds? So they're saying on this velocity versus time graph at 2.5 seconds, what's the value of the speed? 6 meters per second. Yay! How'd you get that? Yeah, you noticed it hit right at 6. Good graph reading skill. What direction is the object moving along at that time? What do you guys think? Positive x. Positive x, because we have a positive value of our velocity. But the value of the velocity is positive, so it's moving in the positive direction. Right, it's changing negatively, so that means it's slowing down. But it's still moving in a positive direction with a positive value. That's one of the hard things to always keep straight in your mind. When we're talking about the value versus the slope. And those things are easy to look at and misinterpret. So now, in fact, the next thing is we're moving on to the slope. What is the acceleration of the object at 2.5 seconds? So again, now we remember back from our y that the slope is the slope of the velocity is the acceleration. So I'm going to do my slope again here. I have a slope, let's say I go from 10 to 2. So my rise is negative 8, right, from 10 to 2. Negative 8. And my run is from 1 to 4, so that's 3. So I end up with negative 2.67 meters per second. or meters per second squared as they write it. And that's my slope during that time. Is the speed increasing, decreasing, or constant? As we just said, it's decreasing. Getting closer to zero, right? Yes? Does everyone agree that that value is getting closer to zero as it transitions from 10 to 2? That means decreasing. Remember that the negative and positive indicate direction. And that's question 1. I'm waiting.